Today we're going to talk about estimating the square root of a non-perfect square. So our I can statement is, I can estimate the square root of a non-perfect square, or I can give a decimal approximation for the square root of a non-perfect square. Let's begin with the square root of 52. Okay, I know that the square root of 52 is somewhere between the whole numbers of 7 and 8, because the perfect square that's right below 52 is square root of 49, and the square root of 49 is 7, and the perfect square that's right above 52 is 64. The square root of 64 is 8. So square root of 52 is going to be somewhere in between these two numbers. So it's going to be 7 point something. Now I need to find the difference between these two numbers, 49 and 52. So I'm going to say 52 minus 49, and I get 3. And then I want the difference between these two numbers. So 64 minus 49, $15. Next, I'm going to take these two numbers that I just found, 3 and 15, so we did the difference between the lower perfect square and the number we're looking for, and the difference between the lower perfect square and the upper. And we're going to take these two numbers and we're going to make a fraction. 3 over 15. Now we're going to take this fraction and we're going to change it to a decimal. Okay, so numerator's in the house and we're dividing by 15. 15 cannot go into 3, so I add a decimal and a 0. 15 can go into 30. 2 times 15 is 30. Now, I have 0.2, and we said at the beginning that the square root of 52 is somewhere between 7 and 8, so that I know it's going to be 7 point something. Well, there's my point, 7.2. So my decimal approximation is square root of 52 is approximately 7.2, and I can check that. I just need to multiply it out. 2 times 2 is 4. 2 times 7 is 14. Put a placeholder. 7 times 2 is 14. 7 times 7 is 49, plus 1 is 50. I'm going to add. And I count the places behind the decimal. 1, 2. So I'm going to move 2 decimal places this way. 1, 2. 51.84. Pretty close to 52.